Welcome back, welcome back, welcome back. I'm Lisa Blackburn. And this is my YouTube channel where I talk about everything I want to, science and math. And we're in AP Chemistry today learning about intermolecular forces, and this is part 2 of the notes, okay? So we're at section 11.5, vapor pressure. There's a diagram in your book on page 443, okay? Let me find where I am on my notes. Here we go. Molecule, so suppose a sample of liquid is placed in an evacuated closed container. Describe what happens to the liquid over time and explain why vapor pressure will eventually reach a constant value. Okay, so imagine we've got like some sort of container and all the air is pumped out, but there's liquid in it. Okay, so what's going to happen to that liquid? What is some of it going to do? It's going to become gas. Do you see that? Because these molecules are all in motion. They're vibrating around, remember? And as they do, if there's one up at the surface, it'll bump it out. And then it'll fly off and be a gas. It'll get enough energy, it can fly off and be a gas. So molecules will evaporate until equilibrium is reached, which means the same number are becoming gas as returning to liquid. So at first, just molecules are being bumped out into the gas. But then if some of them are flying around and it hits the surface, then there's those forces of attraction. It can get pulled back into the liquid. But to start with, there'll be more becoming gas than becoming liquid. But eventually, this air up here, this area will be saturated with gas. And it'll have the same number becoming liquid as becoming gas. Okay, so that's what happens. What is the dynamic equilibrium that occurs in the situation described in part A? And it's the rate of evaporation equals the rate of condensation. So one equals the other one. Okay, may I scroll a little bit? Okay, so volatile. Define the term volatile as it applies to a liquid. And that's, how easy it becomes a gas. What does volatility suggest about the strength of a liquid's intermolecular forces? So volatile is the ease with which a liquid evaporates, and it is called volatile if it evaporates easily. Therefore, do you think it has strong or weak intermolecular forces if something is volatile? Weak. Yes, y'all are doing great. Y'all are getting it. If you get this, I promise you there's going to be a question on the AP test about this. And if you just sort of understand these, you're going to get it. All right, so here's another little thing. So this is talking about temperature, the number of molecules in the temperature. Okay, so we're going to look at the diagram above to explain how vapor pressure of a liquid is affected by increased temperature. So this one is got a lower temperature. I'm going to go ahead and label it. And this one has a higher temperature because kinetic energy is increasing that way, temperature is increasing that way. You follow the diagram? Okay. So as temperature increases, kinetic energy increases, right? And a greater amount have enough energy to escape the liquid form and be converted to a gas, causing the vapor pressure to do what? To increase or decrease? What's going to happen to vapor pressure? We've got our closed little container. We got liquid. Liquid is becoming vapor. We heat it up. Is that vapor pressure going to increase or decrease? Increase, yes. Which is going to cause vapor pressure to increase. Okay? Liquid starts to boil when its vapor pressure is equal to the external pressure above a liquid. So usually when you're boiling things, it is not in a closed container. It's on your stove. So when does it get to boil? It gets to boil when the vapor pressure up here is equal to, that's coming off the liquid, is equal to the atmospheric pressure. So before that, the atmosphere squishes those particles back down to liquid. But then it will boil when it reaches that vapor pressure, and then it can come up. Now, this isn't evaporation. Evaporation is the molecules just bumping up into being a gas. This is boiling, and boiling is when that vapor pressure equals atmospheric pressure. Okay, so the normal point, boiling point, is defined as what? 1 atmosphere. So do you think things boil at a lower or higher temperature in the mountains? Is it going to be over 100 degrees or under 100 degrees? Under. Because there's less vapor pressure, so it boils less atmospheric pressure, so it boils easier. So that's why on your brownie mix, sometimes I'll have different directions for if it's in the mountains. It'll tell you to cook it longer. Have y'all ever seen those? That's why. Okay. Describe how boiling point of water is affected by this different situations. So if it's a high altitude, pressure decreases. So it's a lower boiling point, and the water boils at less than 100 degrees. A pressure cooker. So is that higher or lower pressure? Higher pressure. So one time my great aunt had a pressure cooker, and it was in her kitchen, and it exploded. It blew up her kitchen like a bomb. And but her insurance covered it, and she got a new kitchen. But the pressure cooker was defective, and I've always been a little scared of them since then. But do I have one? Yes, I still have an Instant Pot. But hers blew up the whole kitchen. Like what killed her if she had been in there? Green beans everywhere. That's what she was cooking. Okay, so pressure cookers, increased pressure. So the boiling point, is it going to be higher or lower?
Higher.
It's going to be higher. So water will boil at higher or lower than 100? Higher. So it's hotter and it cooks faster. That's why the Instant Pot is faster. Okay, which of these liquids has the weakest intermolecular forces? Which liquid has the strongest? Okay, so here we've got diethyl ether, ethyl alcohol, ethanol, water, ethylene glycol. That's in antifreeze. Okay, so looking at that, which one has the weakest?
Diethyl.
Yes, the diethyl ether. Do you see how it becomes vaporized the easiest? It boils the fastest, it evaporates the fastest. Diethyl ether, okay? So it has the lowest boiling point, the highest vapor pressure, it's the most volatile. So which one is going to have the strongest intermolecular forces of all of these? Which one is the strongest? Ethylene glycol. In fact, its boiling point is way over here somewhere, off the graph. It's so far away. So it is the ethylene glycol. Now, I wanted to show you the abbreviation IMF. If you see that on the AP test, stands for intermolecular forces. Okay, that's why I abbreviated that there. I was like, they need to know that abbreviation. Okay, last little bit, and it's straight out of honors. You already know it. Phase diagram. Phase diagram is a graphic way to summarize the conditions under which equilibria exist between different states of matter. On the generic phase diagram below, label the x-axis and y-axis, identify solid, liquid, and gas regions, and label the triple point and critical point. So on this side, we have pressure. I'll just write it here. And on this side, we have temperature. Okay, so the lowest temperature, is that going to be solid, liquid, or gas?
Solid.
Solid, so this region is solid. Okay, the highest temperature, what is that one going to be? Gas. And in between, liquid. You remember this from honors? We did this on a test. Okay, and then that is the triple point, where they can all three coexist at one temperature and pressure, where you've got all three states of matter together. Okay? The last little thing says in your book it talks about liquid crystals, but they're not on the AP exam. You're welcome to read it, but we're not going to cover it. Okay? Like, share, subscribe. Science is great.